Now, what happens if we are not given a slant height and we are just given the height of a pyramid? Well, like I said, sometimes the slant height, okay, is not given for a particular pyramid. Okay? So that would be the case of one like this here, where we're given a height. It is often easier to find or be given the regular height of a pyramid rather than the slant height. Okay, so sometimes we're given the regular height. So in this case here, that would be this line, the 4, rather than the slant height. Using the height and the base, we can determine the slant height for the pyramid. All right, so what we're going to be doing here is we're going to be trying to find what the slant height is for this pyramid. Now, the slant height, and I'm going to quickly draw that in there, is from this point down to here, and that's going to be at a right angle. Okay, it's at a right angle, so that is the height right there. We can think of it as this is a right angle triangle, kind of like that, where we know this side here, and we also know that this length right here is 3. How do we know that? Well, it is half the base. Okay, it's 1/2 the base. That's what that length is. Okay, so it's half that length, so that would be this side right here. Then, so we've created a right angle triangle. Now we can solve for the hypotenuse, okay, or h. Well, sorry, that's wrong. That would be our slant height, actually. We can find our slant height for this piece right here, and that's supposed to be an S, not a 5. Okay, that's supposed to be an S. All right, how do we do that? Well, we start off using Pythagorean Theorem. And let's see if maybe we can get a squared. Let's see if we can get a squared here. I believe there should be. Maybe not. I'll have to draw it in later. Right now my program is glitching out on me. A squared plus b squared is equal to c squared. So when we draw that in, and I'm just going to quickly draw in my squareds. Again, the joys of technology. We have squared, squared, squared. Okay. Well, this will be, we'll call this our A, this our B, and this our C or S. Okay. And so when we punch it in there, and I'm going to try doing this a little bit differently here. A squared would be 4, so that's 4 squared. And then we're going to add B, which is 3 squared. Remember, that's half of the length. And that's going to equal to C squared. Okay, 4 squared is 16. 3 squared is 9. And that equals C squared. We add this together. This is 25. Still equal to C squared. And then to get rid of the squared, we take the square root of these two. This is going to be C, and the square root of 25 is 5. So this side is actually 5, not just S. So this would tell us that our slant height then is 5. So then we could go through and we could actually find our surface area using that slant height of 5. Use Pythagorean theorem, use a right angle triangle to come up with our slant height. Here's a short little example, okay, that we can do. So let's say the model of the Great Pyramid of Giza was constructed for a museum. The model has a base length of 50 inches. Okay, so this here is B, our base length, and a height of 17 inches. There's H. Find the surface area of the lateral area of the model. Well, what we need to do is we need to find the slant height first. Okay, and I'm thinking my program is still not so great, so we're going to use our drawing tool in this case here to go through it. Okay, so to find this, this is our base, this is our slant height. So we're going to do 25 inches squared plus our height of 17 inches squared. Now I'm using 25 because it's half of that, is going to equal to our slant height squared. Remember our triangle here was half the length of the base, right? So if our base is 50, it's going to be 25. Now if we do this here, and you can use your calculators for this here, we do 25 squared plus 17 squared equals 914. We take the square root of that, and we get 30.23. And that then is our slant height, 30.23. S is equal to 30.23 inches. Then we can find the surface area of the model. In this case, we're being asked for the lateral area. Okay, so we're only needing to find the lateral area. So remember, that's just the outside. Those are just the triangles. So all we're going to find are the triangles. And we're going to try this here again. Okay, so we're going to find the triangles. So that is base times height divided by 2. Okay, I'm going to use that for divided by 2. Again, a little bit basic due to the fact that my math symbols are not working for me right now. Maybe what I can do, try this here. A little bit bigger. Surface area is equal to, there we go, base times height divided by 2. And we're going to multiply that by 4 because there are 4 triangles. And really that is all we need to do. Okay. So we know our, oh, sorry, I'm going to make this into S. There's our slant height. So then to solve surface area is equal to the base, which is 50 inches, times the slant height, which we said was 30.23 inches. And we're going to divide that by 2, and then we're going to times it by 4. Because again, we have 4 triangles that we need to solve. Let's get rid of those brackets. There we go. All right, surface area. And again, we just need the lateral area because we're not doing anything with the base. So it's just asking us to find the lateral area. This is 50 times 30.23 divided by 2 times 2 or times 4. And this is 3,230 inches squared. And that then is our surface, our lateral area for the model. Now that's just lateral area. We didn't find the base. We could do that as well. That's 50 squared. But we were just looking for the lateral area of the pyramid. All right, your assignment. Questions number 6, 8A, and 9 through 11. Those are ones dealing with rectangular based pyramids as well as slant height and having to find the slant height.